Okay, in this lesson, we're going to be looking at inequalities in one variable. Our objectives are to understand how to graph an inequality in one variable and to understand how to solve an inequality. Our vocabulary is inequality, statement that one quantity is less than or greater than another. Compound inequality, two inequalities put in one statement. Here are the inequality symbols. These first four are the most commonly used. This last one here is used a little bit less. This one just means that the two numbers are not equal to each other. So they're anything bigger or smaller, just as long as they're not the same. So first we have less than, which is saying the left side is smaller than the right side. Then we have greater than, which is saying the left side is bigger than the right side. Then we have less than or equal to, which is saying the left side is smaller or equal to the right side. And then we have greater than or equal to, which is saying the left side is bigger or equal to the right side. Here I have four inequalities and their graphs that go along with them. I want to kind of explain what these graphs are and how we get them from the inequality. So in this first one we have x is greater than or equal to 4. So what we do is we put in our numbers for our number line, typically put the number in the middle. So here I have 4 and then numbers on either side. We can count by whatever we want, decimals, fractions, ones, twos, whatever. What we focus on first is, after we have our number line, focus on the symbol and whether it's equal or not. If it's equal, we're going to have a closed circle because that means that that number is an acceptable answer. Notice here's an equal sign, we've got an open or a closed circle. Here there's no equal sign, we have an open circle. Then we want to figure out, does our arrow, are we talking about answers that are on the right or the left of our number? So here we're saying x is bigger than or equal to 4. So since x is supposed to be bigger or equal, well, bigger is always the right side, so our arrow goes to the right. Let's look at our next one. Again, we've got our numbers down, negative 0.85, or negative 8.5 in the middle here, and numbers on either side. No equal, so we have an open circle. This says x is smaller than negative 8.5, so we want all our numbers on the left. The third one here, 11 is less than or equal to x, so we want to open or a closed circle. Numbers already down, 11 in the middle, closed circle at 11, and then this is saying 11 is smaller than x, meaning x is bigger. So our x's are the numbers that we want. So those are represented by our arrow. We want the right side. This last one's a little different. It's called a compound inequality. And for this one, we need numbers that are going to cover all our numbers. So we need to look at our small and our big. We need to go from at least 2 to 7. I like to have numbers on either side. So I've gone from 1 to 8. And since the 2 is next to a symbol without an equals, we have an open circle. Since the 7 is next to a symbol with an equals, we have a closed circle. And since the x is in between them, I've connected them with a line. And what that's showing is all our answers are between these two numbers. Next, we want to look at how do we solve an inequality. So I'm going to do this twice. I'm going to do it with the box method and with the balance method so that you guys can see both situations. So first I'm going to start with the box method. I'm not going to distribute or combine like terms because there's only one x. Usually we put an equal sign in here, but this one is a less than sign. When there's an inequality, you should always wait and kind of see, if you use the box method, to see if there is any division or multiplication by a negative number that will change our answer a little bit. So we're going to minus 1 times by 4, and add 3, which means minus 3, divide by 4, and plus 1. So I look in this middle column, there's no division or multiplication by a negative number. Here we've got division, but it's a positive number, divide by 4. So that means we keep everything the same. So this is a less than symbol, it stays less than. In the next problem you'll see what I mean here. So we're going to start with negative 5, gives us negative 8, divide gives us negative 2, add 1, we get negative 1. Okay, let's look at this for the balance method. So this time we're going to distribute 4x minus 4 plus 3 less than negative 5. Combine our like terms, 4x minus 1 less than negative 5. Okay, add 1 to both sides. 4x less than negative 4, divide by 4. Okay, again, we're dividing by a number, but because it's a positive number, we don't do anything to the symbol. We go x is less than negative 1. Notice, same answer. Now let's look at one where there is division or multiplication by a negative number, and I'll talk about why that's important. Now in this one we have multiple variables, so we need to combine like terms before we do our box or balance method. So 2x and negative 4x are going to give us negative 2x plus 5 is greater than or equal to 3. So I'm going to write that for both of these. Okay, so I'm going to do the box method for this one. Notice I don't put the symbol in right away for inequalities. And times by negative 2, we're going to add 5, meaning minus 5, and divide by negative 2. Because this situation right here, division by negative 2, what that means is we're going to cause everything to become opposites. Well, the opposites means we need to change our symbol right here to its opposite. So instead of a greater than or equal to, we need to use a less than or equal to. And then we just do our work. So 3 minus 5 is negative 2. Negative 2 divided by negative 2 is 1. So there's our answer right there. Now let's see what that looks like in the balance method. So I'm going to subtract 5. Negative 2x greater than or equal to negative 2. The reason it stays that is I didn't divide or multiply by a negative number. But our next step we will. I'm going to divide by negative 2. Because I divided by this negative number here on the bottom, I have to change it to a less than or equal sign. Always change it to its opposite. This is going to give me x is less than or equal to positive 1. Alright, this has been inequalities in one variable. If there is any part of this that you didn't understand or you need to see again, please pause, rewind, and rewatch, and bring any questions to class. Thank you.